In section 12.3, we're going to focus on the linear sequences, which we're going to now call arithmetic sequences and series. I want you to be able to find the indicated terms of an arithmetic sequence and find the sums of the arithmetic series. So sequence list, series sum. All right, linear functions have a constant first difference, and since the ordered pairs of an arithmetic sequence, and I left out a couple letters there that you can put in, since they form a straight line, you can think of an arithmetic sequence as a linear function with sequential natural numbers as the domain. So, for instance, 1, 2, 3, 4, these are our fifth terms. Those would be our domain. This would be our range. Now, if we're looking at this sequence here, we can see that the differences are 5. And this is the first term. This is the second term. This is the third term. And so our first term, we would have, the domain would be 1, the range would, this should be a -3, that doesn't quite look like a 3 there. Second term would be 2, third term would be 7. So we could graph those as an ordered pair and it would be a line. Now, because the first differences are common or constant, the sequence could be arithmetic with a constant difference of 5. If we look at the other one over here, we look at the differences and we can see that there is not a common first difference. So the sequence is not arithmetic because the first differences are not common. All right, now we're going to go down to the general rule for arithmetic sequences, and I usually have the D on the other side. It doesn't really matter, but you can see this is what we used for linear. Okay, so now we're going to find the nth term given an arithmetic sequence. First thing that we want to do is find the common difference. So if we're looking for the nth term, which would be 12, we're going to let 12 equal n, and then we write our sequence. We know it's arithmetic, and this is the general rule. We're looking for the 12th term. Well, what do we have here? We have the first, second, third, fourth, fifth, and we also have, we know if we subtract -4 minus 2, we're going to get -6, and it's going to be -6 all the way across. So this is arithmetic. This is the common difference, so that gives us D. So D equals -6, and A sub 1 equals 20. So we can fill those values in. We're looking for the 12th term, so we'll put 12, the subscript here, because remember these are the term numbers down here. And then the first term is 20, that's A sub 1. The common difference is -6, and then because this is 12, 12 goes here. Our subscripts we're going to put inside the parentheses here. So this subscript would be 12, that subscript would be 1, so that's why it's 12 minus 1. And then you can just simplify, and you'll end up with A sub 12 equals -46. All right, now if we're finding the missing terms in an arithmetic sequence, we have three terms missing in the middle here. Now, because we're working with series and sequences, I don't want you to just try to guess the difference and then fill them in. I want you to actually use the technique and use the rules to find these out. So what we have is we have A sub 1 and we have A sub 5, and change that to a -7, please. So if we write the general rule and then start filling things in, I usually put the highest term number on the left and the lowest one on the right, and it really doesn't matter just as long as you remember that the numbers that go in parentheses have to go in order from left to right here. So we have A sub 5, we have A sub 1, we don't know what the common difference is, and then we know we have n minus 1 here. So when we start filling things in, we know that A sub 5 is -7, we know that A sub 1 is 17, plus, we don't know what our difference is, but our subscripts here are 5 and 1, so those are the ones that go into the parentheses, our term numbers, 5 minus 1. And as we simplify, we can see that D is going to equal -6. All right, well, how does that help us? Well, we can then go back up here, and the difference between each term is -6, and you can either go from right to left, or you can go from left to right when you're doing this. So 17 minus 6 is going to be 11. If we subtract 6 again, we're going to get 5. Subtract 6 again, we'll get -1. Subtract 6 again, we'll get -7. So now we have that, the missing terms filled in. All right, now another thing that you need to be able to do is find the nth term given two terms. Now, I do this a little bit differently than your book does. So we're going to scratch a couple of these things off here. We want to find the fifth term of the arithmetic sequence. We're given a sub 8 and a sub 14. Okay, so those are what we're going to put into our rule. I'm going to put a sub 14 here, a sub 8 here, plus our difference. And again, the term number is going here from left to right, so 14 minus 8. All right, now we can start filling some values in. We can fill in 157 for a sub 14, 85 for a sub 8. We don't know what the difference is yet, but we do know that our term numbers are 14 and 8, so we subtract those to get 6. And then we can solve for D, which is 12. All right, now that we have D, we have to go through this process again to find the fifth term. So I'm looking for the fifth term, and we're going to use a sub 5. I can use either a sub 8 or a sub 14. It really doesn't matter. So I chose to use a sub 8. So I'm going to put a sub 8 here, a sub 5 here, and then our difference, and we know what that is. We'll fill that in just a minute. And then our term numbers go in the parentheses, so 8 minus 5. Now I can fill in the value for a sub 8. That is 85. We're looking for a sub 5. We know our difference is 12, so that goes here, and 8 minus 5 is 3. So now when we solve, we can see that a sub 5 is 49. Okay, on the next page, we're going to look at the sum of the first n terms of an arithmetic sequence. So maybe we'll want to add the first 5 or the first 10 or the first 15. You cannot find the complete sum of an infinite arithmetic series, but you can find a partial sum. So what we're going to do, this is the notation for find the first 12 terms. This as well as this is the summation, and we start with k equals 1. You can start with k equals whatever you want, but if we start with k equals 1 and we go to 12 and we put the rule right here, these two things mean the same thing. They mean that we want to find the sum of the first 12 terms. Okay, so this is how you find the sum of the first 12 terms. And if you think about it, it really does make sense. What I'm going to do here is, let me get a scrap piece of paper, and we know that 1 plus 2 plus 3 equals 6. Okay, so that's the sum of the first 3 terms here. Now, if I would average these out, I could take a 1 away from here and make that a 2. I could, and then add it to this one to make that a 2. So 2 plus 2 plus 2 is still 6. So that's kind of what we're doing here. We're taking the average of the first and the last term, and then we're multiplying it by the number of terms. So if I would, now just pretend these aren't scratched out, if I would take the first term, which is 1, the last term, which is 3, divide it by 2, this would give me 2, and if I multiply it by 3, I'm going to get 6 back. So that's basically what's going on here. Now remember, these are partial sums. So let's do an example here. We want to find an indicated sum for the series, and I'm going to have you write the series down here. We want to find the first 18. If we add the first 18 terms in the series, we want to find what the sum is. And I don't want you just to figure out what the difference is and then do this 18 times. You need to do use the arithmetic series, or I will not give you credit for that. So the first thing that we're going to do after you write the series down, we're going to find the common difference, which is negative 11. So subtracting from right to left, negative 20 minus a negative 9 is negative 11. All right, and it didn't really give you a whole lot of room here, so I hope you can see what's going on. Okay, so we're going to identify what we have. N is 18, a sub 1, our first term is 13. We need a and we have a common difference, which is negative 11. We want a sub 18 because we need the first term. We have that. We have the ratio, or sorry, not the ratio, that would be for geometric. We know the common difference is negative 11. And so let's find a sub 18 with that information that we have. So the 18th term, we need to do a sub 1, or a sub 18, equals a sub 1 plus our difference, which is negative 11, and then because these two are our term numbers, they go in the parentheses, 18 minus 1. All right, when we go and solve for that, we can put our first term in, a sub 1, and this is just going to end up being negative 187. So a sub 18 is negative 174. Now, we have our first term, we have our last term, and we have how many terms we have in the series. So we just fill those values in. S sub 18, oops, I think I need to move this over a little bit. And there we go. S sub 18 equals 18, and then in parentheses 13 plus a negative 174 divided by 2. And if you simplify that, that's going to give you negative 1,149. All right, now you have another problem that is finding the sum, but it's in summation notation. So what we're going to do is we need a sub 1, so I'm going to put 1 here. So 5 plus 2 is going to give me 7. And then that's the first term, and now I need the last term, so I have to put 15 in here. So 5 plus 2 times 15 is going to give me 35. So there's my first term, and there's my last term. And I don't need the common difference here. I just need how many terms I have, the first term and the last term. Okay, so that's a little bit easier to do. We're going to take 15 because that's the number of terms I want to add together. A sub 1 is 7. A sub 15 is 35, and then I divide by 2, multiply by 15, and I have the sum of 315. Okay, the last thing that I want to do is to give you a practical application of where you can use this. And let's say that we have a concert section, or a center section of a concert hall has 15 seats in the first row and 2 additional seats. Well, if each row differs by 2, that's going to be the common difference in each subsequent row. So we want to know how many seats are in the 20th row. Well, let's first figure out, so if we want to add 20 rows together, we need to know the number of rows we have, the number in the first row, the number in the last row, and then we take the average. So our first row has 15 seats in it. The common difference is 2. So let's find how many are in the 20th row. So that means we need to do a sub 20 equals a sub 1 plus my difference is 2. And I'm going to put my term numbers here are 20 and 1, so 20 minus 1. And then I'm going to put in a sub 1, and then when I simplify this, it's 38. So the number of seats in row 20 is going to be 53. So that's just row 20. We want to know the total in all of the rows, all of the 20 rows for the next question. So we want to know the sum of the first 20 seats. First 20 rows, I should say. Okay, so now, in order to do that, we need the first number in the first row, number in the last row, and the number of rows we want to add together. So the number of the rows we want to add together is 20. Number in the first row is 15. Number in the 20th row is 53, and then we divide by 2. So when you simplify that, you have 680 total. Okay, now you have a few questions to do on your own.